Now, what we're going to look at is the last topic in this chapter. Inequalities. Okay? We're starting now, so listen please. I'm just going to wait till everybody's listening. Thank you. So, inequalities. Just before I get started with inequalities, well, no, I'll give you know them already, really. There's less than or equal to, greater than or equal to. Okay. Now, just before we talk about this, I want to just introduce some notation which you may or may not know. So the first one here, this here is called, well, does anybody know what this one is? It's real numbers. Yeah. The set of real numbers. So basically, every number we've dealt with so far is inside of this set. So for example, 4, root 2, pi, these are all real numbers. The next one now, this one here, this Q, does anyone know this one? Yeah, rational numbers, but what is a rational number? Basically fractions, okay? So like 1 over 3 is a rational number, 2 over 3 or minus 2 over 3 is a rational number, 4, rational number. So all the fractions like this are rational numbers. So that's the first one. That's the next one. Okay, next one now. Does anyone know this Z here? What is it? Integers, yeah. In other words, all the positive and negative whole numbers. So like 0, plus and minus 1, plus and minus 2, plus and minus 3, and so on. And there's one more, N. What's this one? The natural numbers. Do I or do I not start with 0?
Yeah.
Which is it? With or without 0? With 0? Without 0? In fact, it's not clear. And in fact, if you look at different books, some authors would include 0 and some will not include 0. Okay? So for me, I will include 0. You seem surprisingly happy with this decision. Yes? And then, if I want to show that I don't want to use 0, what I'll do is I'll put a little star here beside it, meaning that I don't want to include 0. Sometimes people write a little, I could keep talking about this, I won't. So for me, N will have 0 and N star will exclude 0. Okay? So we have R, Q, Z, and N are 4 basic sets. Okay. Do you have those 4 taken down? R, Q, Z, and N.
So can you go up a little bit?
To here?
Yeah.
You write these down, Hassan? Yep. Okay. Okay. Next now. New page? Yes. Okay. Suppose I'm only talking about numbers between 2 points. Like for example, all the numbers between 1 and 6. So for example, let me call this, I don't know, A, for example. All the numbers between 1 and 6. So for example, 1 belongs to A, 2.5 belongs to A, square root 2 will belong to A. But it's a little bit inconvenient to be writing this all the time. So there's a different way to write this, all the numbers between 1 and 6. And the way we write it is like this. Square bracket 1, comma 6, square bracket. This here means all the numbers between 1 and 6, including 1 and 6. And then if I didn't want to include 1 and 6, if I wanted something like this, all the numbers between 1 and 6, but don't include 1 and 6. Any ideas? Has anybody seen this before? Yeah, I use the round brackets, 1 and 6 like that. This has a special name. This is called a, does anybody want to know it? This is called a closed set. And then this one here will be called an open set. Include 1 and 6, exclude 1 and 6. So for example, 2 belongs to B, 2.5 belongs to B, but 1 does not belong to B. Okay. Okay, now let's have a look at some questions now. So just quick recap, we have R, Q, N, and Z are 4 sets, basic sets, and now we have this new notation, a closed set and an open set. Okay, so let's have a look at an example here. So for example, I would like you to solve this problem here. Minus 5x less than or equal to x plus 6. Okay. Well, this is really exactly like the first lesson, linear equations, except for one thing which we'll see in a moment. So I take the x over to the left and I get minus 6x less than or equal to 6. And then here I get x greater than or equal to minus 1. And what you need to know here is when you multiply or divide by minus, then that makes a flip in the sign. So here I divided by minus 6 to cancel. And whenever I multiply or divide by a negative number, I flip this around. So that gets flipped into that. With this one additional rule, it's really identical to what you've been doing in the first week. Just need to remember to flip when you have negative multiplication or division. So there's the answer. The answer is x is greater than or equal to minus 1.
Sorry, if you are moving on a negative x.
So no need to change it if it's just like what I did at the beginning. If I just bring it over like that, no need to change it. It's only when the multiplying or dividing comes in. Yes? You're unconvinced. I promise you this is true. Yes? And here, if you don't want to take my word for it, for example, if I have 4 less than 10 plus 1, if I take that plus 1 to the other side, is this still true?
Yes.
Still true. Now, suppose I have 4 less than 10, and I multiply both sides by minus. Is this still true? No, it's false, because minus 10 is further to the left on the number line. So minus 10 is smaller than minus 4. So now this is false. Okay? So you're allowed to bring positive and negative over to each side when you're adding or subtracting, but when multiplying or dividing comes into play, it flips the sign around. It flips the inequality around. Are we happy with that first example? Or other questions? Okay. So that's first example. That is just a linear inequality. Okay. Let's have a look at a little bit more difficult of an example. Minus 11 less than or equal to minus 4x plus 5 less than or equal to 13. Now, any ideas for this?
You said 325.
Yeah. If you want, you can separate this into 2 separate problems to solve separately. But it's okay, actually, if you keep it together as one. You just need to be very careful. I don't want this 5 here, right? So what I'll do first is I'll do a minus 5 on each of the 3 parts. So first thing was minus 5 goes on to all 3. So now I get minus 16 less than or equal to 4x less than or equal to 8. Is that okay?
It's minus 4.
Minus 4x.
Sorry, I dropped the minus going here. Thank you. Oh, and I should also say, the question tells me at the start, I'll just stick it up here, x is a natural number. Okay. Now, what should I do next? Divide everything by minus 4. So here that becomes 4x minus 2, but because I divide by minus, these get flipped around. Okay. Now, we haven't dealt with the fact that x is a natural number. Okay, so is this answer fully right? I mean, is the answer x is between, let me draw it here. -2, -1, 0, 1, 2, 3, 4. Yeah, I can't use minus numbers, yeah? So, because x is a natural number, yeah, yeah. Now, I have something embarrassing to tell you. Remember earlier when I said about the n and the n star? I got them exactly the wrong way around. So my n has no 0 and my star has 0. So on one of them put a star and then on the other one delete the star. Okay. Now tell me this, can I write my answer like this? From 1 to 4 close brackets? No. Why not? Because when I write it like this, I include all the numbers between 1 and 4, including fractions. Whereas I only want natural numbers 1, 2, 3, 4. I don't want 1.5, right? So I shouldn't use that. Instead, I should use this. 1, 2, 3, and 4. That's the answer. Now, I'll definitely do another example of this, okay? So write this one down. Yes?
Couldn't we just write x is n?
X is what?
What's the e on?
X belongs to n.
Yeah, x belongs to n and x is from 1.
You could, but sometimes in the exam, they will say and want the answer exactly like this. So it's just safer if I say give the answer like this in case that happens. Yes?
Isn't x greater than -2 or -1 or
Yeah, but also in the original question, I tell you that x is a natural number. So I exclude those negatives. Will I do another example now? Yes? Okay, so how about I do 2b here? So I have -11 less than or equal to 2x minus 17 less than or equal to 5. What should I do first? Add 17 to everything. So plus 17 onto this, what do I get? 6. Plus 17 here. Cancel, and plus 17 here. Yeah. Is it minus 2x? Okay, thank you. And add 17 onto everything. Yeah. Okay. Next, I divide everything by -2. So here, -3, and what happens here? Flips. And then here? Thank you. And here? -11. Now, if I draw this, it goes from -11, -10, etc., 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 to -3. The question also says x is a integer. So, do I use all of these? Some of these? What do we think? I use all of them. So my answer is -11, -10, -9, dot, 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 all the way to -3. That's my answer.
Can't we use the set?
No, because if I use the closed set, minus 11 to minus 3, it would include the fractions also. Yes? The only time you really need to use the closed set is if in the question I tell you x is a real number, which is going to happen in my next example. Okay?
So can we just do the dot 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 thing?
Oh yeah. You mean like if you gave your answer like this?
Yeah.
It's fine, yeah.
So what does the symbol stand for?
Which one?
Next to x?
Yeah.
The E.
That means x belongs to or x is a integer. So I'm saying here x belongs to this list, or x could be one of these numbers. Basically, it's more convenient than saying x equals minus 11 or x equals minus 10 or x equals minus 9. It means the same thing. Okay, next example. Alright, next example. So far we've done linear. Let's have a look at quadratic. Now, the way to solve this quadratic, now there's many ways to solve it, but the easiest way to solve it is first, I'll just write down my ABC, so A equals 21, B equals 32, C equals 12. And then I'll use my quadratic formula. So I get two answers. Minus 2 over 3 is my first answer, and minus 6 over 7 is my second answer. Now, what shape will this quadratic be? U or hill? U shape. So there's my 2 points, and I draw the U, and it's like this. Okay? Now, this is how you get your answer. What you do is, you look at this piece here. You want your quadratic to be positive or equal 0. Your quadratic must be positive, right? Here the quadratic is positive. Here the quadratic is negative. And back here the quadratic is positive again. Do you see that? Positive, negative, positive. So you only want this here and this here. So if you look, you want your x to be smaller than this, and you want your x to be bigger than this. Yeah?
Why does it need to be positive?
Say again? Why does it need to be positive? If you think about it like this, this is your quadratic, and it's a bit like saying y equals that when I draw it. So by saying this needs to be positive, it's like saying y needs to be positive. So you're only looking at the positive y.
But isn't x a real thing? X belongs to R, so
I'm confused. Say that again?
x belongs to R, so it doesn't matter if it's positive.
Doesn't matter if x is positive or negative, right? But you need this formula of x to be positive. So for example, if I put in x is 0, what do I get? 12. So 0 is fine. If I put in x is minus 0.5, I'll tell you now that the answer will be negative, which you don't want. And the reason, not minus 0.5, let's say minus 0.7. So if I put in minus 0.7, this will not be positive, so I can't use that. And the reason I know this is because I know if I choose x in this piece, I'll get negative numbers, but if I choose x here, I'll get positive, and if I choose x here, I'll get positive. This is what you want. Questions? Yes? Oh, I'll definitely do another one, don't worry. But I'm not quite finished yet, because these are my answers, but I need to write them as sets. So my first piece, where does it start? What's the beginning out here? Yeah, minus infinity. And where does it stop? Minus 6 over 7. Closed or open? Here. Closed or open? Closed. And here? Open, very good. And then what about this one? What would that be? Closed. Minus 2 over 3 to infinity. And then open. Now, these are both my answer, right? So, does anybody know the symbol for sticking these together? That's it. You write a U between them. U meaning unite or union. So, your answer is stick these two together. Okay. I'll give you a minute to write this down now, and then I'll do another one. It's not a very big question, it's just difficult to understand. Yes?
I didn't why did you create an infinity?
Yeah, the reason is you want this yellow piece here, yeah? And if you look at it, this yellow piece goes all the way to the left where minus infinity lives. And this positive one here goes all the way to the right where positive infinity lives. So this is this answer, and then this one is this answer. Okay, I will do another example now. Do you want another one like this or one more difficult?
There's one more difference.
I'm getting mixed reactions here. I'll tell you what, I'll do another one like this and then a more difficult one. So what I'll do is this one here. Y equals minus 7x squared minus 41x minus 63, and x is your real number again. Right, so using our ABC formula, let me write in the inequality. This one's a little bit more difficult. Okay. Let me make space here. This one here is not greater than or equal to 0. It's actually less than or equal to minus x squared. No, Ahmed. It's not as difficult as that. I did hear you right, didn't I, when I heard your reaction? Yes? Yes? I did hear you right, okay. It's not as bad as it looks. All I need to do is take this to the left, and now it's much simpler, okay? So if I take minus x squared to the left, it becomes positive. So minus 7x squared plus x squared, what's that? Minus 6x squared. Less than or equal to 0. Okay, now I'll use my formula for A, B, and C. A is minus 6. B is minus 41 and C is minus 63. I get two answers, minus 7 over 3 and minus 9 over 2. So minus 7 over 3 and then minus 9 over 2 are my two answers. Okay. What shape will this quadratic be? A hill shape, yeah. Again, I'll stick to my same colours. Yellow for positive, yeah. and then let's say blue for negative. Now, do I want positive or negative here?
Negative.
Negative. I want negative, yeah?
We changed the -7 to -6.
Yeah, because I brought this to the left.
Oh.
So do I want negative or positive? Negative. So that means I want this piece here and this piece here. So again, I want x to be less than or equal to -9/2 and x to be greater than or equal to -7/3. Putting those two answers together, -infinity to -9/2 and, sorry, close, and -7/3 to infinity. So here, let me color it again. This one here is this answer. And then this one here is this answer. Once you bring the x squared to the left, it becomes exactly the same. Yep. If you look at the inequality sign, it's less than 0, which means you want your quadratic to be negative. And your quadratic's only negative underneath this y-axis here. If this was greater than or equal to 0, you'd want positive, which would be the yellow piece. Just so you know, guys, if it was greater than or equal to 0, what would the answer be?
-9/2.
-9/2 to -7/3, close, close. If it was positive, you would want this piece, which would be here to here. If it was positive, but it's not. It's negative, so it's this one here.
Previous one was positive, and this is the
Yes, and the reason for that is because this quadratic is a different shape. It's a hill shape, whereas the previous one was a U shape. So some people might be trying to figure out if you can tell if you need the inside piece or the outside piece by looking at if it's positive or negative. You can't. You need to look at if it's positive or negative and if it's a U shape or a hill shape. So the only really way to be certain is if you do a rough sketch. So although you're not asked for it and you don't need to do it, you really should do a sketch so you can figure out the right part to take for the answer. Okay, once you have this taken down now, I'll do 4a.
4a.
Yep. Okay, 4a now. So in 4a you have 71 less than or equal to 2x squared plus 20x plus 49 less than or equal to 97, and x is a natural number that includes 0. Okay. Here, I really do need to separate into two problems. So the first one is 71 less than or equal to 2x squared plus 20x plus 49. And then the second problem, 2x squared plus 20x plus 49 less than or equal to 97. So I've split them into two. there is the problem on the left, and then in red is the one on the right. Oh, that's okay. You can't see the question now. It's 4a if you need to write it down. Or will I undo that? Don't need that. Okay, so on the left I get 2x squared plus 20x, and then if I do here 49 minus 71 is minus 22, and then here 2x squared plus 20x, and then 49 minus 97 is minus 48. So 2x squared plus 20x minus 48 less than or equal to 0. Okay? First quadratic will have answers, let's see, 2, 20, minus 22, 1 and minus 11. So here my answer is 1 and minus 11, and then here 2, 20, minus 48, 2 and minus 12. Okay. This first quadratic, U-shape or hill shape? U-shape. And this one here? U-shape. I want it to be greater than or equal to 0. So which numbers do I use here?
Both numbers.
Yeah, but do I want the inside or the outside?
The outside.
The outside. I want x to be less than or equal to minus 11. And here? Here? X is greater than or equal to 1. Here I want less than. So what do I use here?
X less than or equal to
Yeah, x between minus 12 and 2. Okay, so if I try to put this on a number line, let me just mark off the key ones. 1, 2, minus 11, minus 12. Okay. My first one says x must be less than or equal to minus 11. Or x must be greater than 1. Now, in red, let's look at my next one. This is and between them. X must be between minus 12 and 2. So there you go. Minus 12 and 2 is all the way there. And then lastly, I say at the start, x must be a natural number, not including 0. So if I put in the natural numbers, there is 1 and 2. Now it's very difficult to see now because I've put in so many different shaded parts, but can anybody think they can tell me what the answer, final answer here is? Well, let me simplify it for you. X must be a natural number, right? So is this one here any good to us? 1 and 2 is right. Yeah, let's work it out. X must be a natural number. Is this any good to us? No. Gone. What about this one? Yeah. X must be greater than 1. But here I say x must be between minus 12 and 2, right? But I've already just said x must be greater than 1. So really, when I put this together with this, what am I saying? X must be between 1 and 2. But x is a natural number, so therefore it can only be 1 or 2. So x can only be 1 or 2. Like a boss. Okay, write that one down. Very difficult. Do you need to go up?
second row. It's supposed to be a L shape.
Which one? No, both are U-shaped because they're both positive x squareds.
But they're
Where?
smaller or equal to 0. It's supposed to be a U-shape, a L shape.
No.
How we can decide that?
The way you can decide is by looking at the x squared. If the x squared is positive, it's a U shape, and if it's negative, it's a hill shape. Only by looking at the x squared part.
There's a part where you said when you look above 0, greater than.
Yeah. Here is greater than or equal to 0. So that means you want this positive piece here. Here is less than or equal to 0. That means you want the negative piece. Yes?
How come X is less than
Because you want the negative piece, which means x must be between minus 12 and 2.
Why do I want the negative?
Because it's less than 0 here. Yes? Hey, focus here. I haven't said we're finished. In fact, we're not finished. Okay? So I need you to write these down, and then the homework is the last 4 in each question. So I'd like you to try these for a few minutes. The last 4 in each question.